Hey everyone, welcome back to the channel. I'm super excited about today's video because we're diving into one of the most practical and impactful applications of natural language processing, building intelligent chatbots. Now, think about it. How many times have you interacted with a chatbot today? Maybe on a website asking about product details, or your smart assistant setting a reminder, or even a customer support bot helping you track your order. Chatbots are literally everywhere. In this video, I'm going to break down everything you need to know about building modern chatbots. We'll cover, first, the fundamental difference between rule-based and AI-based chatbots. And trust me, understanding this is crucial. Second, we'll explore the two superpowers of AI chatbots: intent detection and entity extraction. These are the secret sauce that makes chatbots actually understand what you're saying. And third, this is the exciting part. I'll walk you through hands-on demos using two powerful frameworks: Rasa for traditional NLP approaches and LangChain for cutting-edge LLM-powered chatbots. By the end of this video, you'll have a crystal clear understanding of how modern chatbots work under the hood, and you'll be ready to build your own. So grab your coffee and let's dive in. All right, let's start with the basics. First up, rule-based chatbots. Now, rule-based chatbots are like that super organized friend who has a detailed plan for everything. They follow predefined decision trees or flowcharts. Think of them like a giant if this, then that system. Here's how they work. When you type something, the bot matches your input against specific keywords or patterns. If you say hello, it responds with a greeting. If you say refund policy, it gives you the refund policy. Simple, right? These bots are great for straightforward, limited domains. For example, imagine a pizza ordering bot. You say, I want to order pizza. It asks, what size? You say large. It asks, what toppings? It's all scripted, predictable, and fast to build. But here's the catch, and this is important. Rule-based bots are incredibly rigid. They can't handle anything unexpected. If someone types, can I get a big pizza with extra cheese and pepperoni, instead of following the exact script, the bot might completely fail or give a generic, I don't understand response. There's no real understanding of intent or context. They're like robots reading from a script without actually comprehending what you mean. Now, let's talk about the game changer: AI-based chatbots. Unlike their rule-based cousins, AI chatbots use machine learning and natural language processing to actually understand what you're trying to say. They don't just match keywords, they comprehend intent and extract meaningful information from your messages. Think about Amazon Alexa or Google Assistant. You can ask, what's the weather like tomorrow? Or will it rain tomorrow? Or even, should I carry an umbrella tomorrow? All different ways of asking, but the AI understands they're all about the same thing: tomorrow's weather. These bots use sophisticated NLP engines. We're talking neural networks, transformers like BERT, and language models to generalize beyond simple pattern matching. They can handle variations, ambiguity, and even context switching in conversations. Now, here's what makes them powerful. They support multi-turn conversations. You can say, book a flight to Paris, then actually make that London, and then for next Friday. And the bot maintains context throughout the entire conversation. Now, the trade-off? They require more development effort, training data, and computational resources. But in today's world, with frameworks like Rasa and LangChain, building AI chatbots has become way more accessible. Let me give you a quick visual comparison to really drive this home. Imagine you're building a customer support bot for a travel agency. With a rule-based approach, you'd create something like, if user says book a flight, show flight options. If user says cancel booking, ask for booking ID. Every possible conversation path needs to be manually coded. It's like creating a massive flowchart with hundreds of branches. With an AI-based approach, you train the bot on examples of different ways people ask for things. The bot learns patterns and can understand new variations it hasn't seen before. It's like teaching a child language. They learn the concepts, not just memorize phrases. And here's a pro tip. Most production chatbots today use a hybrid approach. They use rules for simple, deterministic flows like, show me the menu, or what are your hours? Because why complicate simple tasks? And they use AI for complex, open-ended interactions where understanding user intent really matters. This hybrid strategy gives you the best of both worlds: speed and reliability for simple tasks, and intelligence and flexibility for complex ones. Now, let's dive into the core concepts that power AI chatbots. First up, intent detection. Intent detection is all about asking one question. What does the user actually want to do? What's their goal? Think of intents as categories of user goals. For a banking chatbot, intents might be check balance, transfer money, pay bill, report fraudulent activity. For a food delivery bot, order food, track order, cancel order, complain about order. Here's a real example. Let's say someone types, I want to send money to my friend. The intent detection model analyzes this text and classifies it as the transfer money intent with high confidence. But here's where it gets interesting. Users express the same intent in countless different ways. Someone might say, transfer cash to John, or send $50 to my roommate, or can you help me move some money to another account? All of these are the transfer money intent, just phrased differently. This is where machine learning shines. We train classification models, using algorithms like logistic regression for simple cases or transformer models like BERT for more sophisticated understanding. The model learns the patterns and can then classify new, unseen messages accurately. In Rasa, which we'll demo shortly, you provide training examples for each intent, and Rasa's machine learning pipeline handles the classification for you. It's incredibly powerful. Next up, entity extraction, which is equally crucial. While intent detection tells us what the user wants to do, entity extraction tells us the specific details: the who, what, when, where, and how much. Think of entities as the parameters or slots that need to be filled to complete an action. For that money transfer example, we detected the intent, transfer money, but we also need to know, who are we sending to? How much? Which account? These are entities: recipient name, amount, account type. Let's look at this sentence. Book me a flight to New York on December 15th for 2 passengers. The intent is book flight, but we also extract several entities. Destination, New York. Date, December 15th. Passenger count, 2. Entity extraction uses techniques like named entity recognition, or NER, which can be rule-based using regex patterns for simple cases, or AI-based using sequence labeling models like BiLSTM CRF or transformer models. In modern chatbots, you often use pre-trained entity extractors for common entity types like dates, numbers, locations, and names. Then you train custom extractors for domain-specific entities like product names, account types, or service categories. The magic happens when you combine intent and entities together. The chatbot understands both what you want and the specific details needed to make it happen. That's when you move from a dumb keyword matcher to an intelligent conversational agent. All right, enough theory. Let's get our hands dirty with some actual code. This is where things get really exciting. I'm going to show you 2 different approaches to building chatbots, using 2 awesome frameworks. First, Rasa. Rasa is an open source, production-ready framework specifically designed for conversational AI. It's been around for a while, it's battle-tested, and it's used by thousands of companies. Rasa gives you complete control over your chatbot's NLP pipeline: intent classification, entity extraction, dialogue management, everything. And it works entirely offline, which is huge for privacy-sensitive applications. Second, LangChain. This is a newer framework that's taken the AI world by storm. LangChain is all about integrating large language models like GPT-4 into your applications. It's perfect for building chatbots that can answer questions from your knowledge base, handle complex reasoning, and even use tools and APIs. Here's what we're building today: a simple restaurant booking chatbot. With Rasa, we'll build a traditional NLP approach with custom intent detection and entity extraction. With LangChain, we'll create an LLM-powered chatbot that can answer questions about restaurant information from a knowledge base. Both approaches have their strengths, and understanding both will make you a much more versatile chatbot developer. Let's start with Rasa. Let's build our first chatbot with Rasa. I'll walk you through this step by step. First, installation. Open your terminal and run pip install Rasa. Once installed, initialize a new Rasa project, Rasa init. Rasa will ask you if you want to train an initial model. Say yes for now. This creates a sample project structure that we'll customize. You'll see several files created. Let me explain the key ones. Domain.yml. This is where you define all your intents, entities, responses, and actions. Think of it as the brain's schema. NLU.yml. This contains your training data, all the example sentences users might say, labeled with their intents and entities. Stories.yml. These define conversational flows. They're like scripts showing how intents and actions connect together. Let me show you what's inside these files. First, domain.yml. This is where we declare everything our bot can understand and do. Now let's define our chatbot's capabilities in the domain file. Here's what we put in domain.yml. We list all possible intents: greet, book table, provide date, provide time, confirm booking, deny, and thank you. We list entities we want to extract: number of people, date, and time. We define responses. These are the bot's replies. For example, utter greet says, "Hello, welcome to Restaurant Bot. How can I help you today?" This structure tells Rasa, these are all the things users might want, these are the pieces of information we need to extract, and these are how we should respond. Next, we create training data in NLU.yml. This is where we teach the bot by example. For the greet intent, we provide variations like hello, hi there, good morning, hey. The more varied examples you provide, the better the bot understands different ways people greet. For the book a table intent, we provide examples with entities marked. We use square brackets and parentheses notation. For instance, I want to book a table for 4 people on Friday at 7 p.m. The bot learns from these examples. When a user says something similar, it recognizes the intent and extracts the entities automatically. Now comes the really cool part: defining conversation flows with stories. Stories in Rasa are like training scenarios. You're showing the bot, when the user has this intent, you should take this action. Then when they respond with that intent, take another action. Let's create a simple booking flow. The user greets. We respond with a greeting. They express intent to book a table. We ask for the number of people. They provide that. We ask for the date. They provide the date. We ask for the time. They provide the time. We confirm the booking. This linear flow teaches the bot how to conduct a multi-turn conversation, but Rasa also handles deviations. If the user provides all information at once, like book a table for 4 people tomorrow at 6 p.m., Rasa is smart enough to extract all entities and skip the unnecessary questions. Once everything is defined, training is simple. Just run Rasa train. Rasa processes your training data, trains the NLP models, and creates a dialogue management model. This takes a minute or two depending on your data size. After training, run the bot in the shell. Now you can chat with your bot in the terminal. Try typing different variations and see how well it understands and responds. It's incredibly satisfying when you see it work. Now, let's switch gears to LangChain. This is where we bring in the power of large language models. With LangChain, instead of training custom NLP models, We leverage pre-trained LLMs like GPT-4, Claude, or open source models like Llama. This gives us incredible flexibility and natural language understanding out of the box. First, installation. Pip install LangChain, OpenAI, Face, CPU. You'll also need an API key from OpenAI or another LLM provider. Set it as an environment variable. The killer feature of LangChain for chatbots is Retrieval-Augmented Generation, or RAG. This lets your chatbot answer questions based on your specific knowledge base, like restaurant menus, policies, FAQs, anything. Here's how it works. You take your documents, split them into chunks, convert them to vector embeddings, and store them in a vector database. When a user asks a question, LangChain retrieves the most relevant chunks and feeds them to the LLM as context, so the LLM can answer accurately based on your actual data. Let me show you the code. It's surprisingly simple. Here's a complete example of a LangChain chatbot with retrieval. First, we import our components. We need Chat OpenAI for the LLM, Face for the vector store, OpenAI embeddings to convert text to vectors, and Retrieval QA to tie everything together. Let's say we have restaurant information stored as documents, menu items, opening hours, policies, etc. We load these documents, split them into chunks, and create embeddings. Now we create and save a vector store. This one-time setup indexes all your knowledge. Now, when a user asks a question, we retrieve relevant chunks and let the LLM answer. Now let's create the chatbot that uses this knowledge base. Here's the complete code. That's it. Now you can ask questions. Question equals, what vegetarian options do you have? Answer equals QA-chain.run question. Print answer. Behind the scenes, LangChain retrieves the 3 most relevant document chunks about vegetarian menu items and passes them to the LLM. The LLM reads that context and generates a natural answer. What's amazing is the flexibility. The LLM can understand questions phrased in countless ways. It can handle follow-ups, and it can even reason across multiple pieces of information. You don't need to train anything. You just need to provide the knowledge base. For a production chatbot, you'd add conversation memory so the bot remembers previous messages, add guardrails to prevent hallucinations, and maybe combine this with function calling so the bot can actually book tables or perform actions. But this foundation gives you an incredibly powerful starting point. So, Rasa versus LangChain. Which should you use? Here's my take. Use Rasa when you need complete control and predictability. Rasa is perfect for domain-specific chatbots where you have well-defined intents and entities. Think customer service bots, booking systems, FAQ bots. Rasa works offline, so it's great for privacy-sensitive applications like healthcare or banking. It's also more cost-effective for high-volume applications since you're not paying per API call. Use LangChain when you need flexibility and natural language understanding. LangChain shines for knowledge-based chatbots, general-purpose assistants, and bots that need to handle open-ended conversations. It's faster to build and requires less training data, perfect for rapid prototyping or when your use case is too broad for explicit intent modeling. In many real-world applications, you might even combine both. Use Rasa for structured tasks like booking or transactions, and LangChain for answering unstructured questions from documentation. This hybrid approach gives you the best of both worlds. The key is understanding your requirements. How predictable are user inputs? How important is explainability? What's your budget for API calls? Do you need offline functionality? Answer these questions and your choice becomes clear. All right, let's wrap this up. Today, we covered a ton of ground. We started with the fundamentals, the difference between rule-based and AI-based chatbots. Rule-based bots are simple and fast, but rigid. AI-based bots use machine learning to understand intent and entities, making them flexible and conversational. We dove deep into intent detection, how bots figure out what you want, and entity extraction, how they identify the specific details needed to help you. Then we got hands-on with 2 frameworks, Rasa showed us traditional NLP-based chatbot development with complete control over every component. LangChain showed us how to leverage large language models for powerful, flexible chatbots with minimal code. Both approaches are valuable, and mastering both makes you a versatile chatbot developer. Here's my challenge to you. Pick one framework and build something this week. Start small, maybe a simple FAQ bot or a personal assistant. The best way to learn is by doing. If you found this video helpful, smash that like button and subscribe for more NLP and AI content. Drop a comment below telling me what kind of chatbot you want to build, or if you have any questions about anything we covered today. Thanks so much for watching, and I'll see you in the next video. Happy coding!